So I want to take a deeper dive into first order processes because they're just a little bit more unique. And just to refresh, the first order process with respect to A is going to plot a straight line when you compare the natural log of the concentration of A versus time. So in other words, this has to be a first order process because the natural log against time made a straight line. Now something that you need to know, only first order reactants have a constant half-life. What that means is that the time that it takes for half of the reactants to get consumed will be the same throughout the entire process. So if we had some data right here, we have the concentration of A versus time. At time 0, which is the beginning of the reaction, you had 100 A's, or 100 was your concentration of A. After 10 seconds, the concentration of A has decreased to 73. After 20 seconds, the concentration has decreased to 50. You'll notice right here, we are at half of our original concentration. From 100 to 50 is a halving of your concentration, and that took 20 seconds. My first half-life here, the time it took for me to use up half of my reactant, was 20 seconds. If you look, to go from 50 to half again would be to 25. And you'll notice it took from time of 20 to time of 40 in order for this reaction to half its concentration again. This is indicative of a first order process with respect to A. You need to be able to look at experimental data and see, okay, it took 20 seconds for me to lose half of my reactants. Then it took another 20 seconds for me to lose a half of the remaining reactant. And since this half-life was consistently 20 seconds both times, it has a constant half-life, this must be a first order process. You should be able to deduce that something is first order either from a graph like this, from a reaction mechanism, or from experimental data where you notice the half-life is constant. Now with first order reactions, you can actually take this a step further where you can calculate the half-life of a reaction by taking 0.693 and dividing it by K, the rate constant for that reaction. By using this equation, if you know K, it's simply 0.693 divided by that K to find how long it takes for half of the products or half of the reactants to be consumed. Or you could go the other way. If you knew that it took 20 seconds for half of the products, or the reactants rather, to be consumed, you could plug a 20 in here and solve for K in order to find your rate constant. But either way, these are unique to first order processes.